Welcome to Astronomy Daily, where we bring you the latest news and insights from the world of space and astronomy. I'm your host, Anna, and today we have a busy episode with exciting developments from across the cosmos. We'll be exploring SpaceX's relentless expansion of their Starlink satellite constellation, with their latest launch adding even more satellites to their growing network. Then we'll journey to China's Tiangong Space Station, where a new crew has just arrived for a 6-month mission. From Mars, we have a remarkable orbital snapshot of NASA's Curiosity rover caught in the act of traversing the red planet's surface. And in the realm of exoplanets, astronomers have made a surprising discovery about super-Earths being far more common throughout the universe than we previously thought. Finally, we'll dive into the recent controversies surrounding potential biosignatures on exoplanet K218b, where claims of possible alien life have sparked both excitement and scientific skepticism. Is this the breakthrough we've been waiting for, or another case of premature speculation? Let's find out together. Let's kick things off with today's news. SpaceX continues its steady pace of Starlink launches, ever growing the company's orbital internet constellation. Last Thursday night, a Falcon 9 rocket blasted off from Florida's Space Coast, carrying the Starlink 674 mission. Liftoff occurred at 9:52 p.m. Eastern Time from Cape Canaveral Space Force Station's Launch Complex 40. Stacked 28 tall inside the Falcon 9 fairing, these newest additions to SpaceX's Starlink mega constellation headed toward low Earth orbit, powered by the rocket's 9 first-stage Merlin engines. The mission represents yet another step in SpaceX's ambitious plan to provide global high-speed internet coverage from space. The workhorse first-stage booster, designated Bone 1069, separated from the rocket's upper stage about 2.5 minutes into flight. 6 minutes later, it executed a precise landing on SpaceX's whimsically named drone ship, a shortfall of Gravitas, stationed in the Atlantic Ocean. This marked an impressive 23rd launch for this particular booster, and its 19th Starlink mission specifically. Meanwhile, the rocket's upper stage continued its journey, successfully releasing all 28 Starlink satellites about an hour after launch. These satellites will spend the next few days maneuvering into their designated positions to join the operational constellation. The Starlink network now consists of more than 7,000 satellites in low Earth orbit. Together, they operate in a grid that blankets nearly the entire planet, with coverage extending to most areas except the polar regions. This network allows users to connect to high-speed internet from virtually anywhere they can point their Starlink receiver toward the sky, whether that's a remote wilderness area, a ship at sea, or regions where traditional internet infrastructure is lacking. Thursday's mission was SpaceX's 47th Falcon 9 launch of 2025, continuing their record-breaking launch cadence. Even more impressive, it was their 30th Starlink mission this year alone, highlighting the company's primary focus on building out this constellation. At this pace, SpaceX is on track to launch well over 100 rockets this year, a remarkable achievement for a company that just a decade ago was launching only a handful of missions annually. Meanwhile, China's space program has reached another significant milestone with the successful docking of the Shenzhou 20 mission at the Tiangong Space Station. The spacecraft arrived yesterday at 11:49 a.m. Eastern Time, beginning what will be a 6-month stay for its 3-person crew. The journey to the orbiting outpost was remarkably brief. Shenzhou 20 launched atop a Long March 2F rocket from Jiuquan Satellite Launch Center in northwest China at 5:17 a.m. Eastern Time, meaning the crew reached their destination in just under 7 hours. This quick transit represents the efficiency of China's increasingly sophisticated crewed spaceflight capabilities. Leading the mission is Commander Chen Dong, who brings valuable experience as this marks his 3rd spaceflight. He's joined by 2 first-time space travelers, Chen Zhonggrui and Wang Jie. Upon arrival, they were greeted by the 3 members of the Shenzhou 19 crew who are currently occupying the station. However, this 6-person arrangement will be short-lived, as the Shenzhou 19 team is scheduled to return to Earth on April 29th, just 5 days after the new crew's arrival. The Tiangong Space Station, which translates to Heavenly Palace, is a T-shaped facility that represents China's most ambitious space project to date. While it's smaller than the International Space Station, about 20% of the ISS's mass, it's still an impressive achievement. China completed the assembly of Tiangong's 3 primary modules in October 2022, though officials have indicated they may add more modules in the future. Shenzhou 20 marks the 9th crewed mission to reach the Chinese space station, demonstrating the steady progress of China's human spaceflight program. Interestingly, the docking coincided with a significant anniversary in space exploration. April 24th marked exactly 35 years since NASA's Hubble Space Telescope was deployed from the Space Shuttle Discovery in 1990. As the Shenzhou 20 crew settles in for their half-year stay, they'll continue China's ongoing scientific research aboard Tiangong, further establishing the country's growing presence in space exploration and cementing its position as one of the world's leading spacefaring nations. Let's head out to Mars now. In an extraordinary development from our robotic explorer on the Red Planet, NASA's Mars Reconnaissance Orbiter has captured what appears to be the first ever image of the Curiosity rover while it was actively driving across the Martian landscape. This remarkable orbital snapshot was taken on February 28th, which marked the 4,466th Martian day or sol of Curiosity's mission. The image, taken by the HiRISE camera aboard the orbiter, shows Curiosity as a tiny dark speck at the front of an impressive trail of tracks stretching approximately 1,050 feet across the dusty Martian terrain. These tracks represent about 11 separate drives that Curiosity performed starting on February 2nd as it made its way from the Gittes-Valles channel. What makes these rover tracks particularly interesting is their longevity. Scientists expect them to remain visible for months before being erased by the persistent Martian winds. As the rover trudges along at its maximum speed of just 0.1 miles per hour, it's creating a visible record of its journey that can be observed from orbit. Doug Ellison, Curiosity's planning team chief at NASA's Jet Propulsion Laboratory, noted, "By comparing the time HiRISE took the image to the rover's commands for the day, we can see it was nearly done with a 69-foot drive." This precisely timed image capture provides valuable documentation of the rover's progress. The HiRISE camera system is designed to take images with most of the scene in black and white, with only a strip of color down the middle. In this particular image, Curiosity happened to fall within the black and white portion. The tracks lead to the base of a steep slope, which the rover has since successfully climbed. Curiosity is currently making its way to its next scientific investigation site, which contains potential boxwork formations. These intriguing geological features may have been created by groundwater billions of years ago, providing potential insights into Mars's wet past. Engineers at JPL must carefully plan each day's journey, considering how the rover's navigation software will handle the challenging terrain it encounters. The rover is expected to reach this new scientific destination within a month or so, where it will conduct investigations that could further our understanding of Mars's ancient history and potential habitability. Next up, in a groundbreaking astronomical discovery, scientists have found that super-Earth exoplanets are significantly more common throughout our universe than previously thought. This revelation comes after astronomers detected a small exoplanet in a wide orbit around its star during a gravitational microlensing event labeled OGLE 2016 BLG 0007. Jennifer Yee from the Center for Astrophysics at Harvard and Smithsonian explained, "We found a small planet in an orbit similar to Saturn's. This planet is part of a larger sample that shows super-Earth planets between the orbits of Earth and Saturn are abundant. The abundance of super-Earths was a surprise." For context, super-Earths are planets with masses up to 10 times that of our own planet, but still significantly less massive than gas giants like Jupiter. What makes this finding particularly remarkable is how it expands our understanding of where these planets can exist. Until now, data from NASA's Kepler Space Telescope mission had established that super-Earths commonly orbit their stars within a distance equivalent to that between Earth and our Sun 1 astronomical unit. However, this new research demonstrates that these rocky worlds are also frequently found at much greater distances from their host stars, approximately 10 astronomical units away. As Yee noted, previously, there were only upper limits on the numbers of super-Earths in wide orbits, and there was a suggestion that they might not exist at all. Based on their calculations, the team estimates there should be around 0.35 super-Earth planets per star in these wider Jupiter-like orbits. This discovery has significant implications for our understanding of planetary formation processes. The distribution pattern suggests planets can be separated into two distinct populations, super-Earths and Neptune-sized worlds in one group, and more massive gas giants in another. This division likely reflects fundamental differences in how these planetary types form. Perhaps most intriguingly, this finding could expand our concept of habitable zones around stars. While Jupiter and Saturn orbit outside our solar system's habitable zone, super-Earths in similar orbits around hotter stars could potentially fall within regions temperate enough to support liquid water, the key ingredient for life as we know it. The discovery was made possible by the Korea Microlensing Telescope Network, which uses Einstein's theory of general relativity to detect planets. When a planetary system passes between Earth and a background light source, it causes a tiny distortion in that source's light, a microlensing event that can reveal otherwise invisible planets. This new understanding of super-Earth distribution throughout the cosmos not only reshapes our models of planetary system formation, but potentially expands the scope of our search for habitable worlds beyond our solar system. Finally, today, there's nothing like a good bit of controversy to get scientific debate going. Last week, a team of astronomers made headlines around the world by announcing what they called the strongest evidence yet for life beyond our solar system. The claim centers around the exoplanet K2-18b, located about 120 light-years away in the constellation Leo, where researchers believe they've detected dimethyl sulfide, or DMS, in its atmosphere. What makes this finding so potentially groundbreaking is that on Earth, DMS is almost exclusively produced by living organisms, particularly marine algae. According to Niku Madhusudan of Cambridge University, who led the research team, these are the first hints we are seeing of an alien world that is possibly inhabited. This is a revolutionary moment. The team used data from the James Webb Space Telescope to analyze K2-18b's atmosphere, detecting not only DMS, but also its chemical cousin, dimethyl disulfide, or DMDS, which is also considered a potential biosignature. Based on these findings, they've suggested K2-18b could be an ocean world teeming with life. However, the scientific community has responded with considerable caution. Several limitations have been pointed out that temper the excitement of this announcement. For one, the DMS detection was reported with only 3 sigma statistical significance, indicating a 0.3% chance it could be due to random chance. This falls significantly short of the 5 sigma standard typically required for a definitive scientific discovery. Critics have also noted that the James Webb Space Telescope seems to be pushed to its technical limits for this analysis, and some scientists suggest the researchers might have used a biased model that artificially inflated the significance of the DMS signal in the planet's atmosphere. Manasvi Lingam, an astrobiologist not involved in the research, stated that concluding that DMS has been detected appears to be premature. Others point out scientific inconsistencies, such as Eddie Schwederman from UC Riverside, who noted the absence of ethane alongside the potential DMS signal, something that should be present based on our understanding of atmospheric chemistry. This isn't the first time K2-18b has been at the center of such excitement. Madhusudan's team previously reported a possible DMS detection on the same planet in 2023, but that finding didn't hold up under independent analysis of the same data. Matt Genge, a planetary scientist from Imperial College London, summarized the situation well. When a discovery is as monumental as the discovery of alien life, the bar is set very high for convincing evidence. The scientific community seems to agree that while intriguing, this potential discovery of extraterrestrial life signals should be approached with healthy skepticism. As astrobiologist Christopher Glein aptly put it, did they find a needle in the haystack or just a sharp piece of hay? The K2-18b case perfectly illustrates the delicate balance scientists must maintain in the search for extraterrestrial life. As Carl Sagan famously said, "Extraordinary claims require extraordinary evidence, and there's perhaps no claim more extraordinary than discovering life beyond Earth." This principle sits at the heart of scientific methodology when approaching potential biosignature detections. The evidence must not just suggest life might be present, but effectively rule out all other reasonable explanations. What we're seeing with K2-18b is science working exactly as it should. Initial discovery, followed by rigorous questioning and alternative hypotheses. Scientists are especially cautious because we've been down this road before. Remember the excitement in 1996 when researchers announced potential microfossils in a Martian meteorite? Or the 2020 claim of phosphine detection in Venus's atmosphere? Both generated tremendous public interest, only to face significant scientific challenges later. These experiences have taught the scientific community valuable lessons about premature announcements. For a biosignature to be truly convincing, it needs to pass multiple independent confirmations using different instruments and analytical techniques. The signal should be unambiguous, with strong statistical significance. Typically, that 5 sigma standard that gives us 99.99997% confidence. And perhaps most importantly, scientists must thoroughly explore every possible non-biological explanation. This is particularly challenging when studying exoplanets like K218b because our understanding of their potential chemistry is still developing. What appears biological to us might simply reflect chemical processes we don't yet understand in these alien environments. As one researcher noted, life is the hypothesis of last resort. Rather than seeing this skepticism as discouraging, we should recognize it as the strength of science. Each investigation, even those that turn out to be false alarms, helps refine our techniques and understanding. We're developing better models, more sensitive instruments, and clearer criteria for distinguishing biological from non-biological signatures. The search for life beyond Earth is a marathon, not a sprint. While K218b may not ultimately provide the breakthrough we're hoping for, it represents an important step in our journey, teaching us how to ask better questions, design better studies, and approach future discoveries with the appropriate blend of excitement and skepticism. Well, that's all for today's episode of Astronomy Daily. We've traveled from SpaceX's growing Starlink constellation to China's latest space station crew, watched NASA's Curiosity rover make tracks on Mars, discovered that super-Earths are more common than we thought, and examined the fascinating but contentious claims about potential biosignatures on K218b. I'm Anna, and it's been my pleasure to guide you through this cosmic journey of discovery. The universe continues to surprise and challenge us, reminding us that space exploration is as much about careful scientific scrutiny as it is about bold exploration. If you've enjoyed today's episode, I invite you to visit our website at astronomydaily.io, where you can catch up on all the latest space and astronomy news with our constantly updating newsfeed and listen to all our back episodes. We're also active across social media. Just search for Astro Daily Pod on Facebook, X, YouTube Music, Tumblr, Instagram, and TikTok. And don't forget to subscribe to the podcast on your favorite platform. Maybe leave a review as well. It helps us more than you would know, and we'd be incredibly grateful for your help in getting the word out there. Thank you for joining me on this astronomical adventure today. The cosmos is vast, mysterious, and filled with wonders waiting to be discovered. Until next time, keep looking up and stay curious about our magnificent universe.